So hello everyone, so I am M.Kaleeswari, the Assistant Professor, Department of Computer Application, the Standard Firehouse, Rajaratnam College for Women, Sivagasi. So today we are discussing about the topological sorting. So we move on to this session now. So first one is, what is topological sorting? So it is an algorithm, it is used to arrange the elements in directed graph in a linear order. So every directed edges u to v, the vertex v appears before the v in the ordering. So this concept is only applicable for directed acyclic graph. So which are the graph that do not have any cycle formats. So first we move on to the what is a tag. So how it is used for this algorithm. So first one is a tag is a fundamental concept of the graph theory. It is used to show how the things are related or dependent on each others in a clear and organized way. So two important features we point out that first one is a directed acyclic graph, each edges and the directions meanings it goes from one vertex to another. So the term acyclic also it's important, that means there is no cycle formation in this graph also. So we move on to the next session. So most commonly the two different waves methods are used for sorting the topological algorithm. First one is a Cannon algorithm. So this is based on the breadth first search based. Next one is a depth first search algorithm. So in this video we focus on the second one, depth first searching. So steps to perform the depth first searching in topological ordering. I will give the demo. So first one is initially the set to track the visited nodes and a stack to store the topological order. Next one is perform the DFS for each unvisited nodes, making the nodes are visited and recursively visiting the neighbors. Next, push nodes onto the stack. Once all their neighbors are visited, repeat the process for all the unvisited nodes in this graph. So reverse the stack to get the corrected topological ordering. So start with the sample example. See the diagrams. So this diagram shows the directed graph with 5 nodes. So A, B, C, D and E. So each connected by the directed edges. So each node has certain number of incoming and also the outgoing edges. So first B has a two outgoing edges and no incoming edges. So the key concept of the topological sorting is the nodes with a in degree of 0 is first ordering in the stack. So in topological sorting, the nodes with the in degree of 0 can be placed at the beginning of the ordering. See the second one. So in this diagram, the first node, it's highlighted or bolded. This is node with the in degree is 0. So B is the first node. In this topological ordering must not have any dependencies. So meaning no other nodes point to it. So this node is the first we can add to the order. So next one is, so once the node is selected, it is added to the topological order. The outgoing edges of these nodes are removed, meaning the connection that depend on their nodes are also updated. So next, after removing the first node, the diagram shows the remaining graphs with updated edges. Once the B is removed from this graph, the connected edges, that is the outgoing edges also be removed. So after removing the first node, the diagram shows the remaining graphs with updated edges, that is pointed in dashed edges. So now you look at the next node with the 0 incoming edges, in degree is also 0. In this diagram, the second node is highlighted as bold. This node can now added to the topological adder. So second one is added to this stack. So next step, this step continues. This process continues for the entire graph section. After adding the second node to the ordering, it is removed from the graph and any outgoing edges are adjusted accordingly. So next node with the in degree 0 is found, adding to the ordering and removed from the graph. This process is repeated for each remaining nodes. So each time the node is removed, a graph gets smaller and a diagram shows fewer nodes and edges. This process continues until all the nodes are removed from the graph. At the end of the process, all the nodes are added to the topological order and the graph is empty. This final topological ordering is shown at the end of the diagram, representing the sequence of nodes with no cycle formation. So where each nodes appear before any nodes to point out it. So this is the topological sorting. So the main algorithms or main real-time program for using this algorithm is scheduling the task, organizing the steps for working with the graphs. Topological sorting is one of the powerful tool. So this is my today's class. I hope, thank you for watching. I hope you found this lecture useful and that it gives you solid understanding of the topological sortings. Thank you.